Welcome to the lecture number 40, dear students. As I explained you last time also, that I have to explain you all these tests of similarity. You are quite familiar with this test of similarity. You all have studied them in previous classes. I mean to say 7 or 8 most probably. So you will find that similar triangles. The basic difference between similar triangles and congruent triangles, you all know that similar triangles, the ratio between sides, they look like same, but they are not exactly same. Shape-wise, they are same. That is very important. But for congruent triangles, you will always find the congruent triangles exactly fit with each other. That is why they are called congruent. And here, in this case, you will find shape-wise they are similar. There are lots of examples and there of that similarity, but we are not bothered about it because in our study, a test of similarity. Trying to understand what is meant by a test of similarity. If three angles of one triangle are respectively congruent, I am using the word congruent. If three angles of one triangle are respectively congruent with three angles of other triangle, then those two triangles are similar by a test. Is that clear? So you will find in triangle ABC, if I consider triangle ABC. Now in this triangle ABC, you will notice that angle A is congruent with angle B, because you will find that I have shown a identical marking over here. So A is congruent with B, as well as you will find that angle B, same marking is here for Q, and angle C is congruent with angle R. So this is how you will find triangle ABC is similar to triangle PQR by a test. At once triangle becomes similar by a test, then there exists one correspondence. This is very important, which is called as one correspondence, because I will write the name of ABC here over here. After writing the name of ABC, I will take precaution while writing the name of PQR. How I write the name of PQR? A is congruent with what? P. That is why if A stands at first position, P must stand at first position. That is very important thing. Likewise, you will find B is congruent with Q. If B is congruent with Q, B stands at where? Second position. So Q must stand at second position. In the same manner, C is congruent with R. But if C is standing at third position, R must stand at third position, and this is how it is called as one correspondence. Then, at those triangles become similar by which test? A test. That means three angles of triangle ABC are respectively congruent with three angles of triangle PQR. Even two angles are also sufficient to prove two triangles similar. Reason is very simple. Because if two angles of one triangle are congruent with two angles of other triangle, then naturally we will find the third pair or remaining pair is automatically going to become congruent. So therefore, ABC is similar to triangle PQR, even though you will find two angles are congruent. Now you will find this is very important thing. At once, these two triangles become similar by a test or a test. Okay. Two angles are also sufficient. Then please look here. First two letters AB, first two letters from here PQ. So side AB and side PQ is going to have some ratio. Same ratio is there between BC and QR. Same ratio is there AC upon PR. So we can draw conclusion that if two triangles are similar by AA test or by AAA test, then the ratio between their corresponding sides. I use very nice appropriate word. What is that? Corresponding. Why do you use that? Because AB, first two letters, is forming one side, and PQ, first and second letter, is forming one side. So that is why AB, PQ, BC, QR and AC, PR. They are called as corresponding parts of similar triangles. So this is how we will find. This is first test, AAA test, or even as I told you that even two angles of one triangle enough to prove triangle PQ. Two angles are also sufficient. So there is no need to have all three congruent triangles. Okay. Now next test is SAS test, which is called as side angle side test of similarity. Try to understand, stressing, I am stressing on the word similarity. I am not saying congruent at all. Similar. Now you will find the statement says that if ratio of the corresponding sides, that means K upon RS is 2 upon 3. Is 2 upon 3. You may think how? Look here. 1, correct? 1 upon 1.5. 1 upon 1.5. So 1 upon 15 upon 10. Because if I drop decimal, I get 15 upon 10. And if I take the reciprocal, then what I get? 10 upon 15. If I get 10 upon 15, 5 2s are 5 3s are. So 1 upon 1.5 is also how much? 2 upon 3. Try to understand this. 1 upon 1.5 is 2 upon. Here it is already given ln and st. 2 upon 3. It is already given. So no need of that. But very important, the ratio between corresponding sides and angle included by them. This is very important. Angle included by the sides which are having the same ratio. Try to understand. And angle included. Included means what? In between. Okay. So you will find that angle L is also congruent to angle S. Then triangle KLM. This is a triangle. KLM is similar to triangle RST. By which ratio? Sorry, by which test? Side angle side test. Fine. If somebody will ask you, if you don't know the ratio of KL and RT, what will be the ratio between KM and RT? Yes, KM and RT will also have same ratio, that is 2 upon 3. But when it is possible, when these two triangles will prove by similar by SS test, in that case KM is also having the ratio as 2 is to 3 with RT. Okay, so here I have written the triangle KLM is similar to triangle RST by which test? SAS test. Okay. If triangles become similar by the test, then what happens? Then remaining parts. There are 3 pairs of angles, there are 3 pairs of sides. So you will find corresponding angles, very important. L and S we have already used to prove for SS test. Which else 2 pairs are left out of angles? K is congruent with R. But why K is congruent with R? Because K and R at where? At the first position, and triangles are similar. Very important. So you will find K is congruent with R. Likewise, this we have already used. For what? Test. Which else angle is left out? Third angle. Third angle is what? N is congruent with T. Right? N is congruent with T. And as I told you earlier also, Kn upon Rp is also 2 upon 3. So this is how you will find this. Second test is SAS test, that is side angle side test of similarity. Then come to the last test, which is called as side test. If the ratio between three sides are same, if the ratio between three sides are same, or ratio of the corresponding three sides are equal, then those two triangles are similar by SSS test. That is our SSS test. Now please try to understand. PQ upon YZ. Very interestingly, figures are given. Not very simple figure to understand you. Very nicely, you will find PQ upon YZ. Now PQ upon YZ. Try to understand. PQ is how much? 2.5. YZ is how much? 1. So you may think, how it comes 5? Very simple. 2.5 upon 1 is nothing but 25 upon 10. And 25 upon 10 is 5 upon 2. 5 is 25, 5 is 10. So this is how PQ upon Y is. The next is QR, right? QR upon XY. QR upon XY. This is also 5 upon 2. It is very simple. 5 upon 2. PR upon XZ. PR is how much? 3.5. PR is 3.5. Upon XZ. XZ is how much? 1.4. So if you take 3.5 upon 1.4, number of digits after decimal are same, 1 each. So you will get it as 35 upon 14. If 35 upon 14, very simple. 7 5 is 7 2. So here you will find again PR upon XZ is 5.2. So this is how, but how to write the name, that is important. So PQ ZY is here. YZ or ZY, when I just say. So PQR ZYX. So PQ upon ZY or YZ. QR upon YX XY. Okay. And PR upon ZX XZ. When I just say. Correct? So this is how we will find these two triangles are also similar. PQR similar to ZYX by SSS test. Next to that, at once these two triangles become similar by SSS test. We considered only the sides. What about angles? Automatically, the corresponding angles are going to become congruent. So you will find here, this 1-1 correspondence is very important. So you will find here, P is congruent with Z because P and Z stand at the same position, first position. Q is congruent with Y, same. Q is standing at the second position, Y is standing at the second position. R is congruent with X, R and X are standing at the third position. So this is very important. You might have studied it in previous classes also in detail, no matter. But you will find here in this 10th standard also, this is a little bit revision of this of the test of similarity. Now we are going to do the next exercise, that is 1.3. Let's have a look at this test. So now I am going to begin exercise 1.3. Then we have to study after 1.3. 1.3, we have to study one more theorem, which is called as theorem on areas of similar triangles. And after that theorem, of course, our last exercise, that is 1.4, and the improvement set. Okay. So this is how you will find. Now I am going to begin exercise 1.3. Please see here, for exercise 1.3, the first question is exercise 1.3, question number 1. Okay. Now we have to prove, or we have to state, right? These triangles are if angle ABC is equal to 75 degree, angle EDC is equal to 75 degree. Then we have to decide the triangles are similar by which test, and then later on we also have to prove, or we also have to write the one-one correspondence also. So I am going to draw the figure now. ABC is a triangle. In this triangle, you will find angle ABC is given as 75. So ABC 75. This is given on page number 21. DEC this angle is given as 75. Okay, students. Question is, first of all, we have to decide whether triangles are similar or not. Okay, very important concept to understand, because very often we have to use the same concept in our sums also. You will find when I say triangle ABC and when I say triangle TEC, you will notice very important thing, that angle C is angle of ABC as well as it is also angle of triangle TEC. So which is called as a common angle, and every angle is congruent with itself. So what happens now? In triangle ABC and in triangle DEC, angle B is congruent with D, that is one pair of the angle, and other pair already is congruent, that C is congruent with C, which I am not supposed to write. It is understood that every angle is congruent with itself. So angle C is going to be congruent with angle C, which is also angle of DEC and which is also angle of ABC. Okay, now one correspondence. So you will find that in triangle ABC, while writing only I take precaution. A, okay, fine. A is congruent with what? A is congruent with E. You may think it is not given. I also agree it is not given, but very simple to understand. B is congruent with D, correct? C is congruent with C. Naturally, if two angles of one triangle are respectively congruent with two angles of other triangle, third pair is automatically going to become congruent. So here E, okay, the third pair is E. B is congruent with what? D, and third is C. So this is how you have to take precaution of writing the names of triangles also with the same sequence in which they are forming a congruent pair. So A is forming a pair with E, B is forming a pair with D, and C is congruent with C. So you will find that triangle ABC similar to triangle EDC by AA test. They also ask us to write one-one correspondence. So you can write ABC one-to-one correspondence with EBC. Clear? So this is how these two triangles are similar by this. Moreover, it is not asking the question, but I am still writing AD upon ED, that is equal to BC upon DC, that is equal to AC upon EC, AC upon EC. Corresponding sides of similar triangles. Okay. Here I finished question number 1. Now I am going to do question number 2 here. In question number 2, you will find two triangles are given, triangle PQR and LN. So triangle PQR now please see, dear students, some things are very important. You might have observed that I am using scale to draw figures. Very important. If we love to do anything, we have to do it wholeheartedly. I can draw with free hand drawing also I can do, but you will always find if we love to do something, we have to do it nicely and appropriately. So I am expecting the same thing from you, that while drawing figures in your notebook, you also must draw neatly with pencil only, not somehow anyhow. These are not instructions to tell you actually at this level. Study we have to do wholeheartedly, not only simply for sake of doing. If you are going to do, you are not going to remember these things in long term. Okay, anyway, now in this figure you will find they have asked us to write by which test these two triangles are similar. And if you will observe it minutely, you will surely come to know that there is some relations between these numbers. How you will find that somehow there is a relation between 3 and 6. There is some relation between 4 and 8. There is some relation between 5 and 10. So, logically you can think that all these sides of triangle PQ are exactly twice that of triangle NMN. So, there exists a ratio. There exists a same ratio in the side LN, PQ, MN, QR and PR and LN. That is 1:2. And if, for example, PQ upon LN, so in triangle PQR and triangle LMN, PQ upon LN, that is equal to PQ upon LN is 6 upon 3 is 2, QR upon MN, that is 8 upon 4, so QR upon MN, that is equal to PR upon LN, PR upon LN, and this all over you will get 2. PQ 6 upon 3, QR is 8 upon 4, 2. Therefore, triangle PQR similar to triangle LMN by which test? By SSS. They are similar by SSS. At once triangles become similar. Very important. P is congruent with L as well as Q is congruent with N. Why? First, second, third. But when it is possible? When the ratios are same. They are called as corresponding angles of similar triangles. So this is how you will find that these triangles are similar by SSS test. I can even write 1-1 correspondence, that is PQR, 1-to-1 correspondence L and N. So very simple sounds that way you will find, but still to understand the concept is important. So next to that is question number 3. Question number 3, 1.3 only. Question number 3, exercise 1.3. For third one, then two poles of height 8m and 4m are perpendicular from to the ground if the length of shadow of the smaller pole due to sunlight is 6 meter, then how long will be the shadow of the bigger pole at the same time? I am not going to write the question over here and wasting the time. I will draw the figure. PRQ and ACB. PRQ. PRQ. This is one triangle. And second triangle is AC. AC. Okay. These are the poles. Name of the poles are PR. That is equal to 4m. Okay. QR is equal to 6m. Shadow of the pole. This is pole. Pole is perpendicular to the ground. Height of the pole is 4 meter and shadow of the pole is 6 meter. So likewise you will find ACB. ACB, in which height of a pole is 8 meter. This is a pole. And you will find shadow of a pole is X. This is a shadow of a pole. X is a shadow of a pole, and you will find AC is a height of the pole, PR is height of the pole, and QR is shadow of the pole. So question asked is, what is the value of X, which is the shadow of a pole AC, which is shadow of pole AC. Now you will find, dear students, that triangle PRQ on triangle ACB, triangle ACB is similar to triangle PRQ. Triangle ACB is similar to triangle PRQ, and we have to find out the shadow of a length. Okay. Now actually they are given us this way. You surely think of it that by which test they are similar. So of course you must think in that way. Side 90 degree and side. So side angle side 90 degree and side. Okay. Because shadow always falls in front of the pole. So this way you will find this is a shadow. Correct? So triangle ACB is similar to triangle PQR by SASS. By SASS. No need to prove it at all. Now you will find, take the ratio AC upon PR. Okay? AC upon PR. That is equal to BC upon QR. BC upon QR. Naturally, you may think this way, why not AB upon PQ? Of course, if triangles are similar by any test, then ratio in the pairs of all three sides are same. So of course, AB upon PQ is also same. But you will find values of AB and PQ are not given and we are not considering them. Reason being that we have to find out value of BC. That's all. So you will find AC upon PR is equal to BC upon QR, corresponding sides of similar triangles. Corresponding sides of similar triangles. Okay. Now value of AC. What is value of AC? AC is 8. What is value of PR? Value of PR is 4. That is equal to value of BC. Value of BC is X. Value of QR is 6. 4 2s are 8. If I transfer this 6 to the left hand side, I'll get X is equal to 12. X is equal to 12 meter. Therefore, length of shadow of pole AC is 12 meter. So this is how, dear students, you will find that if these two triangles are similar by some test, we prove them similar by SAS test. No need of proving them, of course they are already, because you will find 90 this pole, this shadow, this pole, this shadow. Then AC upon PR is equal to BC upon QR. Getting value of X, which is the length of shadow of pole AC, and that is equal to 12. I think we can even finish fourth question, but I'll not go for it. Reason being that it's a little bit complicated figure is there and lots of explanation is required. If I not give you a proper explanation of that, you may not understand it. So that's all. So this is how you will find we have finished lecture number 40. That is exercise 1.3. So till now you must have found out very simple sums. A little bit complicated sums will begin. That's all for today. Thank you very much.